Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be looking at a problem that involves the mean value theorem. We're going to state the theorem and then illustrate it using the function that's given to us. So the mean value theorem, specifically involving derivatives, states that if f of x is continuous on the closed interval from a to b, and it's differentiable on the open interval from a to b, then there exists a c which is inside the open interval from a to b, where the derivative at c is equal to the slope between the endpoints of our interval. So there's the statement. And then we're going to illustrate that. So what we need to do, we've got a few things we need to find. We need to figure out what the derivative is. We need to figure out the slope between, in our case, between -1 and 1. And then we need to find out where c is. So let's do each of these pieces here. So we've got f of x is equal to 2x cubed plus x squared. The derivative, f prime of x, is going to be equal to 6x squared plus 2x. And then we need to find the endpoints. So f of -1 is equal to 2 times -1 cubed plus -1 squared. And so that looks like -2 plus 1, so that's -1. And then f of 1 is equal to 2 times 1 cubed plus 1 squared, and that's equal to 3. Okay, so now let's plug that into our mean value theorem. So f prime of c, so instead of x in my derivative, I'm going to put c in there. So I get 6c squared plus 2c is equal to the slope between my endpoints. So that's going to be f of 1 minus f of -1 all over 1 minus -1. So let's clean this up. So 6c squared plus 2c is equal to f of 1, which is 3, minus -1 all over 1 minus -1, which is 2. So on that right-hand side there, we get 4 over 2, which is 2. So we get 6c squared plus 2c equals 2. Now I'm going to go ahead and bring the 2 over, and then we get a quadratic that we need to solve. So we get 6c squared plus 2c minus 2 is equal to 0. I'm going to go ahead and divide everything by 2 so that it's a little bit simpler. So we get 3c squared plus c minus 1 is equal to 0. Now I have to factor this, or I have to solve this. Solving it by hand is going to be a little bit tricky. You can use completing the square if you want to. But here I think it's just going to be easiest to solve it using the quadratic formula. So c is equal to -1 plus or minus the square root of 1 squared minus 4 times 3 times -1 all over 2 times 3. So let's simplify that down a little bit. So we get c is equal to -1 plus or minus the square root of 13, because 4 times 3 is 12, times -1 is -12, so 1 minus -12 is 13, all over 6. So we get two different values. C is equal to -1 plus rad 13 over 6, and then C is equal to -1 minus rad 13 over 6. And both of these could be answers, because it just says that there exists a C that could be more than one. So in order to figure that out, you're going to want to use a calculator to come up with the numerical equivalent, or the decimal equivalent, or the decimal approximation of this. And if we do that for the first one, we get 0.43. So that's certainly in our range. And then if we do that with the second one here, and we get negative 0.76 or 77. So both of those values are in the interval from -1 to 1, and so these are both c values that work. So at 0.43, we get a derivative that's equal to 2, and then if we go to negative 0.77, we also get a derivative that's equal to 2, and that's it. So if you have any questions, feel free to put them in the comments below, and if you have any other problems that you'd like to see, feel free to put them down there as well. I appreciate you watching, and I will see you in the next video.